So whatever the data you pick, for that data you will be representing in a very good organized form. So that is coined as a statistics. It is very simple. So probability we can define as a likelihood. Okay, x-axis in order to show the independent variable, and it uses y-axis to show the dependent variable. Bar chart are used to compare values across the different categories using the rectangular bars. Hello everyone, I welcome you all to the first session of Unit 3, that's under Statistical Computing and R Programming. This is a 5th sem subject. The unit is nothing but statistics and probability. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor under Department of Computer Science, Vidhyaashram, Temple of Excellence, MYSURU. So moving forward, let's understand what is the agenda of today's session. In today's session, we'll be discussing like what is statistics and what is probability. Then followed by, we'll be also discussing the data visualization. So we know R programming is used in order to represent the data in a visual format, right? So we'll be understanding like how the data is being visualized and what are the different types of data visualization. So these are the agenda of today's session. Statistics is all about collection of data, correct? Even here we see like if we want to represent our information like a log of data, then we can say yes, it can be easily represented in a form of statistics, because in statistics we'll be getting the information in a proper arranged way. So let's see what exactly statistics is. So yes, statistics is a collection, analysis as well as interpretation, then followed by presentation and organization of the data. So whatever the data you pick, for that data you will be representing in a very good organized form. So that is coined as a statistics. Then followed by, we can say under statistics we will be using multiple mathematical techniques. Okay, so yes, we will be using mathematical techniques in order to summarize our data as well as describe. Also, we draw the conclusions based on the description what we get. So yes, this is all about statistics. When we know this, statistics is so important and it provides an efficient organized information for us, then absolutely it will be having multiple applications, right? So yes, statistics is used in various applications, like it is used in medicine, it is used in business. Also, it is also used in social science in order to represent the things or in order to maintain a set or log of a data, and followed by engineering. Also, there are multiple ways, that is nothing but the e-commerce sector. So yes, absolutely, we have a lot of applications for statistics. So this is all about statistics. Now let's move forward. Over here, let's understand what are the different key aspects of statistics. So the first one is data collection. Data collection is nothing but whenever you want to represent your data, the first step will be gathering the information, right? So yes, that gathering information is nothing but data collection. And the next one is data analysis. So using the data, what we have gathered, we will be initially visualizing like what is that the gathered data, what are the information it is having, and how to represent the data. So all these things will be analyzed. So that's where the second aspect is. The third one is data interpretation. For example, if we want to represent or conclude something regarding population, what with respect to which we have maintained the statistics. So for that, we can interpret the different types, like what is a different caste, what is the population of different creed. So there will be multiple ways, correct? So in order to represent that, we can go forward and interpret it in a well organized form. So that's all about our data interpretation. Then followed by data presentation. So this is a very important point where the statistics is being utilized. So that's in data representation. So now when we gathered information, we have interpreted the data, and then next thing what we want is to represent a data in a well organized and in a very good way. So we'll be using different visualization techniques to do that, right? It is all about the data presentation. Like I'll be presenting my data in a form of pie chart, or I can represent my data in a form of bar graph, or in a scattered plot, whatever it may be, but it looks so well to see. And instead of seeing that log statistics of data, if you see a small representation, visual representation, it will be very eye-catchy, as well as you'll be getting efficient information from that. So this is all about the key aspects of statistics. We have understood what is statistics. Moving forward, let's understand what is probability. So yes, probability. So this we have studied from our basic school days. It is very simple. So probability we can define as a likelihood. Okay. So we can see here it is a measure of likelihood of an event occurring. So whenever we consider an event, I'll be writing the internals. So there will be two options. Either I'll be writing a internal, or I'll be skipping it, or I'll be absent for that. So that's a very small example. So if we just convey or consider this probability, we can say it is nothing but a likelihood of a event occurring. There will be only two options, whether I can be absent or I can be present, right? So in the same way, probability is represented in the form of either 0 or a 1, where if we get a probability of 0, then what it represents? Yes, it's none other than the event is impossible. And if a probability is 1, then we can say, yes, the event is certainly possible. So this is all about a probability. So this we can define by using a formula, that is P of E, which is equal to number of favorable outcomes to the total number of possible outcomes. Okay, so this is nothing but a probability, and followed by, if we consider a speech example, so for that we can see, if we roll a dice, the probability of getting a 3 is 1 out of 6. So P of 3 is equal to 1 by 6. So this is a basic example. Whenever you consider probability, the example what we get in our brain is a dice example, right? I have just selected that as we correlate a dice easily when we consider probability. Now let's see an programming example for this probability. So we have considered probability of rolling a 6. So now how we can write it in a R format? We have defined the outcome, that is 1:6. So the probability of getting 6 is 1, correct? And the total number of outcome is 6, right? So that's why we have considered 1:6 followed by favorable. So this favorable is been assigned with length of outcomes followed, which is equal to 6. Then I have a total probability, like the total outcome. So it is been represented as length of outcomes, then followed by probability. So how to calculate probability? Favorable event to the total event. So that's what we have defined. Then followed by, I have to print the value what I get. So this is a simple example, that line of code for defining our probability function. So now let's see what are the different key concepts that we utilize when we define probability. The first thing that comes in our mind is an experiment. So yes, whenever we consider an experiment, then we can see there will be multiple outcomes, right? So out of those outcomes, we will be just going with the total outcome as well as the favorable outcome. So that's why it is being correlated with the probability. Next is the outcome. Outcome is nothing but, as we know, it is a result of an experiment, then followed by event, that is a set of events, like it might be one event according to your requirement, or there will be multiple events. It depends on the requirement or the specification what we define. So these are the different key concepts that we can correlate when we consider probability. Next, moving forward, let's understand the basic rules of the probability. So the first one is addition rule, where we can see probability of A plus B, or A or B can be defined as P of A plus P of B minus P of A and B. So this is addition rule. Next is a multiplication rule, where we can see that probability of A and B can be defined as probability of A into probability of B intersection A. So this is the addition rule as well as a multiplication rule of probability. Let's move forward. So up next is the data visualization. Data visualization is the process of creating graphical representation of data to better understand as well as communicate insights. Correct, right? Whenever we have a availability of data representation in a good pictorial form, then who will see the statistical log? Nobody, right? So that's where we'll be utilizing this data visualization. And as we know, in our first session itself, we have already defined that R programming provides a very good set of data visualization. So for that, we are again going in depth with understanding what is data visualization and what are the different data visualization techniques or types. So this is all about data visualization, then followed by importance. What is the importance of visualization? It makes complex data easier to understand. Then followed by, it reveals the trends as well as the patterns. Like if you just go and verify your statistical data, then it will take a longer time to just verify the things and to reveal the things. So instead of that, if you just go ahead and see the pictorial representation, it will be very easy, right? So that's where it is used in revealing the trends as well as the patterns. Then followed by, it helps in decision making. Absolutely, when you get a easy data, if you consider a pie chart, over there you can see you can easily pick the data, correct? You can easily make the decision like how it is possible and what are the things that we can include in order to make it a better representation. So up next is it supports in statistical analysis as well as the probability studies. So this is a key importance of visualization. Moving forward, let's see what are the different types of data visualization. So this we have already been studying from first, that's from our unit 1. Again, we are studying the thing that's the data visualization even here in our third unit. Let's start studying with a bar graph. Bar chart are used to compare values across the different categories using the rectangular bars. So whenever we specify bar graphs, then the image that comes into our mind is nothing but a rectangular bars, right? So yes, that is nothing but a bar chart. Then what does the x-axis shows? So yes, we have considered an example where we are representing the x value with the categorical values and y has a values, okay? Then followed by common types includes horizontal stacked as well as grouped bar charts. So even in bar chart we have multiple representations, so which is nothing but horizontal bar graph or the stacked bar graphs as well as the grouped bar charts. So this is all about bar chart. So let's see a simple example over here. We can see we are defining a library that is ggplot, correct, right? So we have studied this. Do you remember ggplot is a library which helps in representing or which helps in defining our data visualizations, okay? So now we have to create a sample data. So for that, I am defining a data.frame where I am representing the values, that is the categorical values as I told, correct? So yes, A to E, these are the different categories. Then for that categories, I am defining the values like for A, my value is 10. So for B, the value is 20. So C, 15, D, 30 and E, 25. So we have defined a group of vector in order to hold these values as well as the categorical values. Then followed by the main step, we have to create a bar chart, correct? So for that, I am defining this ggplot. So this is a keyword which represents our data visualization. So inside that, I have to define the data frame df followed by axis. So x represent categories, right? And y represent values, then followed by bar. So you have to see here we are defining a bar chart. So if we consider directly ggplot, we have multiple data representation types, correct? So in that which is being specifically called. So we have to be very specific with respect to that. So over here we have represented a bar. So you can see stat is nothing but identity. So this is the simple example. Now let's see the representation. So as we saw, the categories there is been defined with respect to our x value and with respect to our y, we are defining the approximate values that we have defined. And you can see this is a representation of a bar chart where we are used the rectangular bars, correct? So this is nothing but a bar chart. So let's move forward and let's see what is the second data visualization technique or a type. So that is the line chart. So line is nothing but a simple line, but yes, what varies there is the values as well as the categories that we define. So we can define this line charts in order to represent the change in the values over time, then connecting data points with the lines, correct, right? So we are representing lines. So we are typically using lines itself in order to form a line graph. Then why it is used? It helps to visualize trends like what is the increase in the value, decrease in the value, or we can also define the stability. So that's where we'll be using this line charts. Then let's see an example. Again, we are calling a GG plot over here. Then followed by the year. So over here we are considering 2015 to 19 and we are representing a value for that, that is 100 is to 180, and I have to define the type that we did in our previous example. We did define bar, correct? So over here for line graph, I have to represent it by a L, okay? That's a lowercase l, then followed by the main heading, what it has to show, main sales over time, okay? Then the X label, it should show year, and the Y label is the sales. So this is how I can represent my line graph by using ggplot. So over here, let's see a data good visualization. So you can see this is a representation of sales over time where we have considered different years, okay? According to that year, I have defined basic set of values and followed by we have joined it using a single line. So that's why it is called as a line graph, all right? So this is all about a line chart. Now let's see what is the next type. So yes, this is a next type of visualization, that's a pie chart. So if we say pie chart, the thing what we get in our mind is a good circle, and in that circle the different categories, right? So yes, it is a pie chart. So this chart is divided into slices where each slice shows a part of the whole. So the size, each slice represent its percentage. So the representation or the category, we call it as a slice, okay? So now again, we are considering an example by using or by defining our ggplot. So now I'm calling that library ggplot2, then followed by I'm defining a sample data set where I'm defining the data frame. So what is my data frame? I'm first representing a vector of 4 values, that is A, B, C, D, then followed by one more vector that's representing values, then followed by creating a pie chart. So how to create that? We have to define, right? ggplot followed by data. I'm defining x and the y axis values, and the fill, what is the slice? It should be filled with the category. So this is the thing, and then followed by the geometry of column, and we are adding a polar, that is a theta value, because as we can see the pie chart, it can also be represented in the 3D forms as well, right? So for that we can also represent a theta value or a theta angle. Then what is the title? So finally I am writing a title, that is pie chart example. So that is a final main program, that's a void program that I am calling. So this is a lines of code for pie chart where I am defining x value, y value, and as well as the third model, that's the third direction, the theta value. So using this, let's see how the pie chart looks. So this is all about a pie chart where we are defined 4 categories, right? A, B, C, D, yes, it's there. And as you can see, the pie chart is representing in a good colorful form, correct? Where you can easily pick and represent the thing and it becomes very easy to make a decision, right? So this is all about a pie chart, how the pie chart is been created easily by using the R statistics. Now let's see the next type of data visualization technique, that's a scatter plot or a scatter chart. So over here we'll be using small dots in order to represent the relation between the values. Over here we can see it shows the relationship between two numerical variables, right? So now it has x-axis in order to show the independent variable, and it uses y-axis to show the dependent variable. So that's where the scatter plot goes. So now let's see a simple example. I'm just defining a data with assigning 1 to 10 into x. Okay, I'm loading that. Then followed by in y, I'm just representing a equation that's 2 into x plus r norm of 10. So r norm is nothing but the normal distribution, or we can also say the random normal distribution. So this is the thing, and then followed by we are creating the scatter plot. In order to do that, what we are calling a plot, followed by we have to define that x, y as well as the mean things, correct? So yes, we are doing x, y as well as a mean. So what should be the title? It should be a scatter plot, right? Then followed by what is the label for that x-axis as well as a y-axis. I am defining it as a simple x as well as a y. Now let's see how this scatter plot looks like. So yes, this looks similar to this, where we will be only using the dots, okay, in order to represent the relations. So this is nothing but a representation of a simple scatter chart. Now let's see the next type of data visualization technique, that's nothing but the histogram. So histogram is nothing but a data visualization technique which displays the distribution of numerical data, and it provides the grouping values where you can define the values in terms of intervals, which is called as bins. It shows the frequencies as bars, and it helps in revealing the samples or in order to spread the patterns in the data and all. So that's where this histogram is used, and we can also say this histograms is very similar to our bar graph. Why? Because even here we'll be utilizing that rectangular boxes. All right, now let's see a simple example where I'm just defining a data that's a normal R norm data of 100. Then I'm creating a histogram. So how is that? So HIST is the keyword that helps in representing our histogram chart. Okay, so inside that we have to represent what is the data and what is the main heading that has to define along with our graph, then followed by the X label and Y label. All right. Now let's move forward and let's see how this histogram can be represented. So this is how it can be represented. You can observe here, even we are utilizing the bars, but it is not a separate bar. It is being connected. So this is in which color? Orange. So as you can observe, we have defined an orange color over here. So yes, in that way the representation will fall. So this is all about our histogram, where we have also defined the x has a value and we have not defined the y, correct? So we have just defined the value, but I have not labeled it. So this is all about the data visualization techniques, and in our upcoming session these are the things which we'll be covering. Like we'll be knowing what are the different probability distributions. We are also discussing the characteristics of the probability distribution, what is the probability distribution function, and what is this PDF all about. Then followed by what are the various types like uniform distribution, normal distribution, also the student t distribution. So all these things will be covered in our upcoming session. So this is all about today's session. Thank you.